The Cartesian plane. What an important concept that was constructed a long time ago. Alright, so what we're going to be talking about is the real number line again, except we're going to develop two real number lines, and we're going to intersect them at right angles to make up this Cartesian plane. So let's just draw the picture. So we have the real number line here. And we're going to label this about the origin. Then we're going to put another real number line. About like that. Intersecting two real number lines. Intersecting. And we call this the origin. Now remember, the real number line is made up of real numbers. This real number line we usually call the axis, and we call it the x-axis. And then this real number line here, we call it the y-axis. Now this is the way this works. This Cartesian plane here is made up of quadrants, and this is considered to be quadrant 1. This is quadrant 2. This is going to be quadrant 3. Okay, and let's see, we got quadrant 4. And it's important that we label these, because a lot of times if we say we're in quadrant 3, we need to at least narrow down our general location. Okay, so our real number line here is made up of real numbers on the x-axis, and then on the y-axis each point, right, is associated, it has a real number. But what about some location out in here somewhere? Well, every point is associated with a real number out here in quadrant 1, for example. So I'm going to label this 1 right here on the x-axis, and we'll say that this is 2. So this point right here, okay, this location is associated with what's called an ordered pair. And this is the way we write this. So 1 is our x, and our y is going to be 2. Okay, so that's a location in the Cartesian plane, let's say in quadrant 1. So as you can see, every single point, right, is associated with some ordered pair. And this first number here comes from the x-axis, and this number here comes from the y-axis. So this thing is made up of course, an infinite number of points, and therefore it's an infinite number of ordered pairs. Now some things that we're going to need to know here is let's see, what are some things I might have left out here? I guess I didn't leave anything out. But we're going to talk about things like finding the distance between 2 points. Okay, which we talked about, finding the distance between 2 points on the x-axis. Finding the distance between 2 points, finding the midpoint. We're going to draw, construct a circle. Not a very good circle, but we're going to do some other things and some of these other sections here following this one. But I think we'll just call it quits on that. So the Cartesian plane, this is we're going to mostly be working with and most of the semester until we get into, I believe, Cal 3, that we're going to be staying in the plane in 2 dimensions. But this construction of the Cartesian plane is going to be extremely useful, especially for visualizing graphs.